Hello everyone. So my name's Kerry, and I am a front-end engineer at Server. And tonight I will be talking to you about Webpack. My first little foray into Webpack world was during a random week at work. And random weeks at Server are basically a week where we get to focus on anything that we want, anything outside of the sort of the standard roadmap. You just pick anything and go away with it. So my first ever random week, I decided that I was going to convert our entire build system and test suite and everything, test runner, from Grunt and Require.js to Webpack. You know, like, be ambitious, I guess. So I'm going to talk you through kind of why and why Webpack's really awesome. So first of all, like, what is Webpack? This is directly from the docs. Webpack is a module bundler. Webpack takes modules with dependencies and generates static assets representing those modules. So exactly as it sounds, you can give Webpack lots of different types of modules. We're not just talking JavaScript here. It could be JavaScript, CSS, images, any type of asset that you have in your code base, and it will give you a static asset back. So we're basically talking here of taking all of your dependency graphs through literally any type of asset and handing you back a bundle. And you can then, you know, use that bundle however you like, go ahead and compress it and use it for production. It's literally as simple as that. So I guess the big question is why, because we had something that already worked, and you know, it seemed a bit, I guess, ambitious using 1 week to try and swap over like all of this stuff, because we have a really big code base. You know, we have a web application rather than sort of a website, and there's a lot of moving parts, so this wasn't really a small job. But these were the main reasons for me. The first one being hot module replacement, which is just like the absolute bomb diggity of everything ever. There will be a slide coming up on that, so I won't go into depth. But code splitting, which is really clever. It's basically a way of saying, if I have this entry point or this entry point, give me like different bundles back. Like split these out for me into like, you know, separate bundles. So you could have one bundle for like your administration panel, and then you could have a bundle for the rest of your application, and then you could just load the parts that you actually need. Or you could code split it down into features, or you know, anything you fancy. A common thing that some people do is like using a common bundle, so you put all your common functionality in there, and then you just load in the other parts that you need. But how you split is like totally up to you. So easy integration with NPM and seamless handling of multiple module formats. I thought this was really awesome because with Require.js we sort of had like a lock-in with AMD, and if you want to use a common JS module, that was kind of irritating. Webpack can also handle like quite old school, like just a global window export as well. So you can literally just hand all these things to Webpack, and it just works it out for you. Loaders, which again I'm going to go into detail on, but it was a standalone reason for why Webpack is a really good choice. Configuration files are easy to understand. I know that's always kind of a debatable one, and different people find different things easy to understand, but I find that the Webpack configuration is easily readable for everyone. And it's easy to make the leap from development to production with the likes of plugins, which is, again, really handy because in our Grunt.js setup, we almost had this kind of segregation of like, well, here's the bit that does dev, and then we've got some assets that have been output, and now we need to pass it to the production task and like do some extra stuff with it. But that's kind of a faff, and Webpack makes it really easy to take care of like your different environments. So easy configuration. I've just put like part of our config here, and this is the real server density config that we have. I've left out quite a lot of parts for brevity, but I'll just scroll you through just a couple of parts here. So we've got our context and our entry, and that's literally quite self-explanatory. This is like the first point that boots up your app. You might have an app.js or a bootstrap or a, you know, whatever kicks off your application, hand that to Webpack. So for us, that's bootstrap. That is literally the entry point to our entire application. And then we set up an output, which again, exactly as it probably looks, we give it a folder and directory and everything, and it will hand us back a bundle, and we can go on our way and use that bundle however we wish. We have a way of specifying to Webpack where we should find loaders. Again, I will go into loaders because they are actually really important. It's kind of how Webpack works. But you can tell it to look in like a whole bunch of places to find your loaders. You've got some resolve options here. So root, we use an array. Basically just a way of saying, if I'm requiring a module, like go look in all these places. So if I require a module called date picker, you might find it in CoffeeScript, and to the right there, we have a templates directory as well. So whether I'm requiring some CoffeeScript or I'm requiring a template, it knows where to look to find these things and where to resolve them. Extensions is pretty handy. This means that when you require a module and you're actually doing a require statement, you don't have to put the extension on the end anymore. Pure laziness, I guess, but it's handy. And then you have aliasing, which works the same way that Require.js did. You can give it a specific path and say, if I'm requiring this module, so in this case I've got sumlib, you will find it here always. Don't do any of your clever lookups. Don't try and find it on your own. Just literally, this is where it is, which is quite handy because we've got a couple of sort of older code where we've literally just pulled the code for a third-party module, put it in a file, stored it in a location, and we have to use those. I did convert over as many modules as I could to being installed from npm, but unfortunately when you have legacy code, sometimes that's not always possible. So we have a few aliases that can take up the slack on that. We have DevTool, which is, I don't know why they call it DevTool, because it's the source map option, but it's a way of specifying how you would like source maps to be handled. We use eval in development. We use a different one in production, but I've actually forgotten what it is. And they've all got pros and cons, depending on speed of compilation, the amount of output that you get back, and so on and so forth. So in the documentation, there's a table that shows you the pros and cons, and it's worth kind of figuring out which one works for you. But eval works really nice for us in the dev environment. And then we have kind of a really magic part, which is loaders. So again, going to go into detail on loaders, but just from the config sense here, we're specifying which loaders we would like to use for which extensions. So when a module is required, it will know, oh, well, I end in .html, throw me over to the mustache loader in this case. And last but not least, just for part of the config we're going to show, is this node block, which seems a bit silly, but it's basically for if you're using a module that can be used on the server and the browser, you might need to mock out modules that are actually only helpful for the server-based version of it. So you can mock out certain things that will cause potentially problems with things like test runners, and that's just an easy way of doing that. So the core premise of Webpack is entry output, which I've kind of mentioned in the last slide, but it really is just a case of giving it an entry point, the first part of your application, the thing that boots everything off, and saying where you want that bundle to live. And once you've installed Webpack, which is literally just an npm install Webpack, you run it with Webpack, and here we've got the watch flag, which is really, really useful because Webpack handles all of the watching for you. So when we were using Grunt, it was a pain because we had to set up a watch task to watch, say, the CoffeeScript files, and then if a CoffeeScript file changed, we would then run, say, the compile task to turn it into JavaScript, and then we might have done something else on top of that as well. And you have all of these different things that get really complicated in terms of linking watching to other things. But with Webpack, you just throw in the watch flag and you're good. You don't have to configure any of that separately. So, loaders. Loaders allow you to pre-process files as you require or load them. And this is like I say, kind of where the magic of Webpack comes in. And these are the real loaders that we use at server density. In this case, you just literally throw out a regex for your file extension and which ones you would like to use. So you'll notice here that like, if it's csx.coffee, we actually want to run it through two loaders. We need to run it through the CoffeeScript loader, and we need to run it through CJSX, which is the CoffeeScript flavor of React's JSX. However, if the file extension contains coffee, but it does not have CSX in it, we actually just want to use CoffeeScript, this CoffeeScript loader. And all of these, you can just grab from NPM again, and really easy to set up. The power sort of comes from the fact that you can chain these together. I mean, the maximum we use is a chain of 3, but you could just keep going. You could do as many as you wanted. And my understanding is that actually writing a loader is really easy as well. It's literally just a function, and you return something, and that is a loader. It can be resolved from anywhere, and node modules is conveniently used by default. So if you've just npm installed all your loaders like we do, the Webpack will go find those. You don't need to tell it anything extra. So loaders allow us to do some really cool new stuff. We can handle things in new ways that were never possible before. So one of the things I decided during my second random week was that Webpack should probably handle our CSS as well as our JavaScript. Makes sense, right? Because at that point we had Grunt handling the CSS, we had Webpack handling our JavaScript, and it just felt wrong. So I added in a style loader. In this case, I just wanted to show that there's two different types of syntax. So there's actually a style loader and a CSS loader, and you can split those with an exclamation mark if you want, for fun. And that allows you to literally require CSS. The same way that you require JavaScript, you can now require CSS. And this is incredibly powerful. Because you have the power to use this any way that you want. You could, in our case, we require a single site.css, which is actually more like a manifest. So that has an import statement for all of our other CSS. And when this gets required, Webpack knows how to handle imports. It can go through, it will parse everything, and it will sort everything out with you. For you, sorry, and it's really clever. But say you wanted to have a component that had a CSS file, like a CSS file per component, you could just require the CSS within the component file. So you now have a one-to-one mapping, and everything makes much more sense. And what that also gives you the power to do is say, well, actually, if I only use this JavaScript for, say, this bundle, say the administration bundle, yeah, I only need this CSS. There isn't that disconnect anymore. You can keep everything together. We would like to move to the one-to-one mapping eventually, but for now, we can't guarantee load order this way. And at server density, we do still have some things where specificity in the cascade kind of messes up. So for now, we're just doing this. And that the site.css gets required within Bootstrap because that's the first point where the app boots. We just load in all the CSS at that point. What Webpack will do is, it's actually pretty clever. It will go through all of the import statements, and I think we've got a lot. It's like 20, 30 import statements, because we have gone down the route of having like one CSS file per component, but we're just not at that point where we can do require it within the component file yet. And what it will do is it will add a style tag, style element to your head per import that it finds. So when we're working in development, we have like 30 style elements or whatever, all inlined in our head. And this works incredibly quickly, compilation is quick, and hot module replacement for CSS comes for free with this. And you're probably thinking, well, that really sucks for production. Yeah, it does. But we can use the extract text plugin to get around that. So at server density, again, this is for real what we use. And we can. This is just in the production config, though. So if the file ends in CSS, what we can do is we can use the extract text plugin, which is kind of magic. And the loaders that you specify, so style loader, and to the right it would say CSS loader, it will run it through them as it would have before, and it will kind of take the output and pipe it to a file for you. So each thing that it gets back, every return from all of these loaders, rather than doing what it would have done and place it in the head, it pipes out to a file for you. So what we can say in the plugins declaration is, well, actually, pipe that all through to site.css for me for production. So I now have my singular JS file, singular CSS file, and I'm sorted. It's kind of magic in the way it works, because it confused me at first how this links to this, but you can provide IDs so that they match up together. If you don't provide IDs, it knows that the first instance that you instantiate should map up with what you've provided in the loader. And that's how you make the conversion over to production. Hot module replacement. I'm just not going to speak for like 10 seconds. Actually, I will. So just in case it's not obvious what's going on, I'm going to change something in the code here. And this is updated without me refreshing the page. Change it back, changes again. And there's a second example. No page refresh. And the reason I wanted to show that specific GIF is it's actually what I posted on Google+. We post a Google+ update at the end of each working day with what we've been working on. This was the real GIF that I used to say, hey, hot module replacement is working. And Richard actually, I think he commented with like, I've actually just giggled out loud. And this has actually been a really big game changer. It's probably the biggest sort of productivity boost I've felt for quite a long time. And it's great, you know. You can say you're working on some form validation logic, you filled out the form, and normally you want to change something, you'd have to save it and then refresh it again, fill the form back out. It's really annoying. Now you can just change the logic around it and everything, state is maintained. So like, how the hell does that work? So first thing was installing Webpack dev server. npm install, and we updated one little part of the output, which was public path, to use localhost on port 8080. And basically, Webpack dev server is really clever. It sets up a small Node.js Express-based server for you. It sets up all of your WebSocket connections for you for communicating hot module replacement socket, like changes over the socket, and it just does all of that for you. So installed that, set up the config, and I added an extra loader, which here is React Hot, for dealing with our csx.coffee files. The one downside to this is that we get hot module replacement, like proper hot module replacement on React code, but if we're editing a view that's backbone-based, there is a page refresh, but it will do the refresh for you. So it's kind of like having live reload for things where you don't have a loader set up that can handle things for you, or you can have the super sweet version where it works like the GIF. React Hot is technically deprecated. They're moving to like a Babel implementation, but because we don't use that anywhere in our code yet, we're just using React Hot for now. It's certainly not dead, it's just they will be moving everyone over eventually. And for us, we just run that with Webpack dev server and these two flags. And the hot flag is actually doing like a ton of stuff under the hood. It sets up all of that sort of socket goodness for you. And like, don't get me wrong, you are more than welcome to set up your own lightweight server. Maybe you hate Node. Like, you can set up your server any way you want. And there is a whole API for dealing with like setting up hot module replacement and placing markers within your own code that have things like hot.accept. And you can set all of that up yourself, but I didn't even bother looking into that route. Webpack dev server just works, so, and it's really nice. So time to go live. Webpack includes like numerous plugins, which I mentioned earlier, and this is really useful because again, you kind of don't have that horrible, well, I need to minify some stuff, so I'll go find what the best Grunt thing is for that, and then I'll configure it and find out what the options are, and it's just kind of awful. these 3 plugins here, we do use a couple more plugins, but I've just cut them out for brevity. You know, these come with Webpack. You don't have to install anything extra. I mean, you can. If you need extra plugins, like, go ahead, install all of those. But these 3 just come with Webpack. And we set up a couple of extra options, which are just the normal Require.js options. You just pass those in, and you're away. And the best part is, because everything's so simple like this, we have a base config, which is literally just an object, and our production config can literally just extend that object with the production like extras, which in this case, we only really have like these plugins and a couple of other bits, and that's it. So your production is pretty much the same as development. You don't get that horrible situation where you're like, well, you know, is it going to work in production? Because you're not really doing any extra post-processing on your workflow. Struggles. Yeah, this wasn't without its downsides, the big conversion. The important thing to point out is that absolutely none of this was to do with Webpack. Like, none of it. These were like my 3 top picks. So we had mustache templates that were like just hanging around with space. And that was working before. We moved to Webpack. Yeah, it broke, which it should have always broken. The mustache loader uses Hogan, which is sort of a layer on top of mustache. And all of a sudden, you know, we had the compilation errors that we always should have had. We were using Lodash via this syntax, where this is like the chaining syntax where you need to call, say, filter and, you know, a couple of other things. And then you would call value at the end to give you like a straight array back. We had cases where we weren't calling value at the end, and it was working. It shouldn't have. And as soon as we swapped over to Webpack and like obviously using the loaders and it's compiling via something completely differently, it all broke. So we had to step through, find out what was wrong, fix all of those. And then the last one was like React.js components were just straight up not loading. We had no exceptions, we had no compilation errors. There was just stuff missing on the page. And this was because we had a couple of places where we were using lowercase letters for React components. And that's not okay. It says in the React documentation that's totally not okay. But it was working. So, you know, I don't know how, but we'll never know. But once we went over to Webpack, all of this was, you know, abundantly clear. So they were struggles and they weren't fun, and it definitely sort of delayed the work. But we were in a place where things that shouldn't have been working but were are now fixed. And Webpack is kind of, well, I guess it's the underlying loaders are very strict. And as soon as I moved over to the CSS, like Webpack handling CSS, straight up the first thing it did was like, you have a syntax error here where there's a colon. And I was like, whoa, okay. And I fixed that. So you do kind of get this layer of protection, which is quite nice. Conclusion, Webpack's really awesome. It's definitely worth playing with. You know, even if you don't want to make the big switch, I find that you don't have that disconnect that kind of existed with Grunt and Gulp. And that's not to say, don't use Grunt, don't use Gulp. Grunt is a great task runner, but we were kind of using it for things that was outside of its job. We have little tasks in Grunt, things like a scaffold command that will scaffold out a new component for you. And that's a great little encapsulated task. But Webpack is a module bundler, and it's really good at it. It doesn't matter what you throw at it. It can handle images. You can, you know, there's ways of telling it, if I'm kind of loading an image in my CSS that's less than 100 KB, auto base64 encode that for me and inline it. Don't load the image. It's really smart. And that's me.